Hello, welcome and thank you for attending to this seminar about quick color and material changes without changing injection parameters. My name is Marta Orozco, I'm an industrial engineer and I'm the DME Key Account Manager. The goal of this seminar is going to be understanding how important a quick change of color or material in plastics manufacture is, and how we are going to be able to save cost while doing these changes, because we are going to do them quick and in an efficient way. So first of all, let me first introduce you DME. DME belongs to the to Hillenbrand, and within Hillenbrand, which is a main company with a 2.9 billion turnover, there are several companies focused on plastic processing, which are DME, Milacron, Moldmaster, and Coperion. So within DME, DME's aim is to be your partner in injection molding process from the very beginning to the very end. That is, from the part design and mold design also to the processing and also the mold and machine maintenance. So we really want to help you on optimizing the mold design, improve your processing productivity, and then obviously with the lowest possible investment. So why making quick changes in plastics, in material or color is relevant for you? Some of the reasons are obvious. It's obvious that we want to increase the quality of our process, right? It's obvious that our goal is to grow the business and increase the returns, but also if we are more efficient in doing the color or material change, we'll have happier employees, right? An employee will be happy if they can make a color change in 1 hour or 30 minutes instead of 8 hours. And also, being more effective here is going to help us with initiatives such as lean manufacturing. And why am I mentioning lean manufacturing? Because at the end of the day, lean manufacturing, which is what a lot of companies are dealing with currently, the goal of lean manufacturing is to eliminate waste and minimize the cost, right? And also, it's lean manufacturing is a pull system, so that is that you only start a new work when there is a demand for it, right? So that what it means at the end of the day is that your customers is going to ask you for intensive color changes and intensive material changes, because you're gonna change your molds very often, right? So you do need a system which helps you to do that in an effective way. And also, lean manufacturing is minimizing the scrap, the waste. So that's something that we want to do. If we can do a color change in 20 minutes instead of 8 hours, obviously this is going to improve our profitability. So how can we evaluate the sustainability of suitability of a purge system? So the first thing we need to think of is the parameters that I need to take into account. So which are the relevant metrics that I need to take into account to evaluate the purchase system? Is it only the material price? No, of course not. We need to take into account all these things here. So what is really my scrap rate currently? Does it mean, how does it translate into material loss? What is the cost of reprocessing this scrap that I'm currently generating? How much extra labor does that imply? And which is the overall cost of it all, right? So this is all that we need to have into account. So it's not only a couple of prices and that's it, yeah? And we'll see a little bit more of that afterwards. So let's start with a very basic example. let's consider that I do a changeover using virgin resin, right? So this changeover is going to take 2 hours for me. The machine running cost per hour is 80 euros. So it means that the machine downtime cost, right, is going to be 160 euros. I'm using 25 kilograms of virgin resin. The price is 1.3. So it means that the total material cost that I'm wasting here, it's 32.5 euros. So the total cost of this changeover is 192 euros, right? That means that I have an annual changeover cost of 46K. Okay? We need to keep that in mind, and we'll use it afterwards. So the next thing we want to do, now that we have an idea about the cost that it might imply in my company, the current purging system, we want to decide which purging system we want to go for. So some common situations that I already faced is that when you talk to some customers, say, oh, I have a homemade purging compound. It's very cheap. I did it. Is it really cheaper? I mean, I even had a customer who told me that they were using corn because of, the expansion, the thermal expansion of the corn. Then some other people may say, no, I'm using virgin resin because then afterwards I recycle it and then I purge with virgin resin. But there are some implications, right? I mean, are you considering then the amount of hours that you're using currently, the effectiveness of the transition, the contamination you are getting into the system? For example, if you use virgin resin, because at the end of the day, afterwards you are going to recycle this resin, perhaps. Yeah. So these are things that you need to take into account really when going for a homemade system. So the challenge is really to understand which are your current cost of the internal solution and compare it to our proposal here. Okay, so there are several systems of doing the color or material changes. So one is using recycled resin. Obviously, if we go for recycled resin, we are introducing pollutants and degraded material. And we have pellets of different diameters, so they melt differently, and it takes a long time. The same with virgin resin. I mean, it takes a long time as well. So time here could be essential for both solutions, let's say. And none of these materials is obviously designed to remove the sticky items that get into that are making our life difficult, right? When we are purging. So then there are several purging systems. So there are mechanical systems, chemical, and hybrid. So the mechanical purging systems usually add additives, right? It's basically is a plastic with some additives on it. Usually they use more or less abrasive material. That's the first difference with our system, that we are not using abrasive material. If we're going to go for mechanical purging, it's nice to know that there is no chemical reaction needed. So so it's just the material gets melted and it cleans. And it doesn't require then some activation time, some soaking time. And it cleans by shear tension between material and the surface. And this is really nice about that. Another possibility is to go for chemical systems, and then these systems do require activation time. And then there is a mixture of the two of those, and these are the hybrid systems. So these are the systems that we can find, generally talking. So which are the critical areas of difficulty in cleaning? You have suffered that much more than I have, so you know that this is in the machine and in the mold, but you also know that it really depends on the material. So reprocessed materials are more difficult then to get rid of, and organic pigments are sometimes a pain to get rid of, right? And where does these materials get stuck? they get stuck mainly in the barrel wall, in the flights of the screw, and in the very end of the machine. Okay. So, what do I need to take into account to clean it all? We'll see now. The first thing we need to know is that the plastic tends to go to the path of least resistance, right? So the plastic is easier for the male plastic to flow here than to flow here, because here there is this friction with the wall, and here there is just more male plastic. So it tends to go to the path of least resistance. Okay, and that doesn't help when you want to purge, because you need to force the plastic to go all over, right? So if you don't purge properly and you want to inject the green part, you can end up with something like that, right? Because if you before had some blue, some yellow, whatever. Okay, so what we want to do is really to try to avoid laminar flow, right? And try to get to turbulent flow. Why? Because in laminar flow is what we saw in the last slide. We have here, we would have 0 speed, and here we'll have the maximum speed, right? While with turbulent flow, we will have the same speed of all molecules all over, right? This is what we want to get. If we have this turbulent flow, we will have shear rate, we will have the friction between molecules in all over the channel, okay? And then this friction is going to take out peel off the contaminants, even in areas of slow flow. So then our system, the one that we are proposing you now, which is called MC2, goes for a high Reynolds number. Okay, and he's getting that obviously with following a process, but mainly because of the ingredients. Okay, so the goal is really, as I said, to create a turbulent flow which is able to get into any hole as small as 254 microns, so into any nook and cranny. Okay, be able to get in areas of low flow. Okay, so then this system is going to be able to remove the contamination in the screw, in the cylinders, but also in other areas such as hot runners. So let's say, for example, I want to mention here that our brother or sister company, Moldmaster, already did several tests with this system in their hot runners, and it works nicely. Yeah. Okay. So this is roughly how it works. This is the turbulent flow creating this shear stress, and this would be the speed, okay, of these molecules. You see, it's not like that anymore, right? Now it's kind of a rectangular profile. Okay, so all the molecules are the same speed, and all chaos and friction between molecules all over. Okay, and as you can see here, it's a mixture, the Fresh Start, it's a mixture of different components, okay, to be able to promote, let's say, this turbulent flow. Okay, so let me talk to you now about an example with a European customer who did one of the first trials here. This customer wanted to inject an ABS part, roughly from its 20 per 30 centimeters, 400 grams, and going from gray to white. These are the characteristics of the machine. And the process that we did with Fresh Start was what you see here. So then you can see that the process is extremely easy. So it's basically first purging without purging material, so to get rid of the ABS, right? Then adding Fresh Start, and then purging again, okay? And then injecting okay? In this case, it was about 12 pieces, so that's 8 kilograms of material. And then adding new material into the mold. Total time for that, 35 minutes. Well, is this customer the first time he uses a purging material? No. No, in fact, this customer was already using an alternative purging material. But what happened? That with the alternative purging material, he had to change the temperature. So it means that they had to add 10 additional minutes to the process. And on top of that, the efficiency of the system was not that efficient, it was not that good, right? So he had to inject 20 additional pieces in order to get to the good production again. So it means that it was adding with the traditional, let's say, purging material that he had, 20 to 30 more minutes. So it's, if you take a look at that, that's roughly saving half of the time, yeah? And you can see here some pictures of that. So why am I mentioning that? Because one of the benefits of the system, of our system of Fresh Start, is that you don't need to change the temperature parameters. That's fantastic because then you can save some additional time. Another benefit that this customer mentioned is that while he was doing the trial, is that this customer is working with a lot of different materials. And so currently he's using a purging for polyolefins, another one for some other material, for technical materials, another one only for the hot runners, With Fresh Start, they can go for only one purging material for it all. You see more. These are this is the process. Yeah. Okay, so that was just an example, and I'm gonna now show you the cost factors and the return on investment in this basic example that we first we saw at the very beginning. In the example we saw at the very beginning, we had this cost. You remember that I said you need to keep that in your mind. If we go for Fresh Start instead of purging with virgin dressing, we go for 20 minutes instead of 2 hours. So you see the difference is mainly here, yeah? So it means at the end of the day, even being the material cost obviously more expensive than the virgin dressing, the saving is incredible here. So look at that. I mean, we are saving, being extremely conservative, we are saving 58% of the changeover cost linked to this particular machine. Right? And as I said, there are a lot of things that are not taken into consideration here, such as having different stocks of different purging materials, the labor, the scrap, reprocessing stuff, things like that. Yeah. So, Fresh Start is the material, the solution that we are presenting you here. As you can see, these are, as I said, the main benefits that we can have is resin type, all types of resin. Temperature range from 177 to 329. It means that any plastic which fits in here is able to be purged with Fresh Start MC2. So that's fantastic. That means really minimizing the stock of purging materials. This is very good here. As I said before, 254 microns of clearance means that it can go into gates which are 0.6, whatever, right? I was discussing that with a shearing manufacturer 1 week ago or so. I said, no problem. I mean, you can go for that. That's not a problem. It's not abrasive, so that's really good, mainly, I mean, for everything, but mainly if we are considering cleaning the hot runners with it, right? And something really interesting as well as it can stay in the cylinder. If you want to seal the cylinder or seal the machine when you turn it off so that you avoid during the weekend or during vacation time, you avoid the material which is in the cylinder to degrade or whatever, you can leave fresh starting, no problem. Yeah? Something really relevant as well is that it's made with safe ingredients according to FDA. Yeah. So applications, is it only valid for injection molding? No. It's valid obviously for injection molding, but also blow molding, extrusion. We had some interesting examples with extrusion lately. So you can really, it's valid. You see, it's mentioned here. It's valid for POM. Okay, not every purging material is valid for POM. Fresh start is. So it's really one system for every purging application you might have. So, if we go for a quick recap, why should you consider Fresh Start Solution? Because it's going to help you increase your production, lower your scrap rate, and also decrease your waste. You are going to gain speed for material changes, which is always good, not only because of the savings that it means, but also because you want to keep your customer happy. And the same for color changes. And it's going to increase your revenue and profitability. So yeah, it would be good to consider Fresh Start because of all these reasons. I would like to, these are some success stories that I would like only to mention here, just for you to see that it goes from, in this case, for example, from polycarbonate to polypropylene, or from polyamide to ABS. So we can really, let's say, play with it. I mean, it's very flexible. It allows to do a kind of different changes. And I just wanted to mention here a couple of examples in this case, just to see in real cases return on the investment, right? So in this case, we have this example, which is a 16 cavity tool with hot runner, okay, and they are using currently a competitor for purging. Well, not anymore now, but they were using a competitor. So with Fresh Start, we had this change, color change, sorry, in 20 minutes. As you can see here, the whole process. Okay, 20 minutes. So you can see it here. With the competitor's purging system, was 90 minutes. Right? This is the main difference. So every day, considering one change per day, we were gaining 70 minutes per machine. Okay. That means at the end of the day that only by changing to Fresh Start, this company gained the equivalent to 2 additional injection molding machines. That's a lot of money. And that's not only a lot of money, but a lot of additional flexibility for your customers. This is another example here. In this case, the purging system was virgin material. Okay, so what they had to do is from black to white, this company, what they ended up doing is cleaning the screw manually. So that meant 8 hours. So you can now imagine the benefits of using Fresh Start here. In this case, Fresh Start is used for hot runners and the cylinder and the screw. Okay, so this is the process that we followed, and after the purge, the purge was 56 minutes in general. Okay. So, what do we see here? Here, the cost of purging difference is incredible. I mean, if you consider that these guys were using 8 hours to clean the screw manually, and then the hot runners, and then against less than 1 hour. Yeah, So the savings is really 10 times the cost of the saving initially. Yeah, it's incredible in here. So if you're currently purging with either virgin or kind of recycled resin, you really need to take into account going for Fresh Start. Okay. This other example is kind of the same, so the savings are the same. I just wanted to show you this one because in this case you will realize that the part is a tampon for women. So that means that yeah, we were purging using Fresh Start for such an health products as this one. Yeah? And you can see here again the difference in cost is incredible. Yeah, and this other example in this case, the change was using it was with a polyamide, glass filled polyamide. Yeah, and it's a part for a car. Yeah, and it was from kind of black to kind of gray brown. Yeah, in this case, the difference it was using they were using another purging material, so the difference was really gain in production time, right? So Fresh Start was faster than the other system they were using up to now. Okay, so just for you to know, we do have this Roi Calculation Excel sheet in case you wanna use it, in case you wanna you know, give it a thought. So these were some examples to help you better understand how useful this can be for you in order to get all these benefits that we are mentioning here, as we just mentioned before, right? Basically, you want to speed up material and color changes and then improve your productivity. Remember that it's ideal for effective elimination of the resins, pigments, and contaminants. Do the quick color changes. Remember that you can clean hot runners as well. Remember it's not abrasive. That's extremely important. That with only one product you will cover much probably all your needs for purging. Okay, and you don't need to change the temperature. Okay, so that means speeding up the process again and avoiding the possibility for operators to do mistakes. Yeah. Remember that Fresh Start can stay in the cylinder. Okay, so you can seal the cylinder with Fresh Start, and it's made of non-hazardous materials. For other specific needs that you might need, we do have another specific solutions. Yeah. So, in case you want to know more, in case you want to go for a test, please deal with us locally, and we can help you with all these initiatives here, with case studies, with initial packages, with an ROI calculator, giving you the instructions for injection, for extrusion, or alternative, contact please DME Europe, and they will be happy to help you. Yeah, we are here to help you, so please feel free to get in touch with us. Okay, I really appreciate your attention, and yeah, I hope to see you soon in another webinar. Thank you.